Hello, my dear grade 8 students, and to all the grade 8 students in the whole Philippines. Welcome back to our class. Again, this is your teacher, Miss Cabs. So, here we are again for our new exciting episode of our science class in Science 8. So, since you already know what is the difference between atom and molecule as what we had discussed in our previous meeting, you also have learned that matter have different properties. So in this video, we are going to talk about the particle nature of matter. But of course, before we proceed to our lesson, if you are new to this channel, don't forget to subscribe, like, and hit the notification bell for more updates in our science class. For today's objective, and that is based on our most essential learning competencies, are you are going to explain the properties of solids, liquids, and gases based on the particle nature of matter. And second, you are going to explain the physical changes in terms of the arrangement and motion of atoms and molecules. At this point of time, we will have our activity. And in this activity, you are going to infer from your observations that particles of matter move and represent through a drawing or illustration what is between particles of matter. Okay, so are you ready? Yeah. So guys, before we proceed to our activity, let me remind you of your pen and notebook so that you can take down notes all the questions in this video. So are you ready? Okay, let's start. Okay, so guys, let's analyze. So from the activity, we observed that we could slightly push the plunger of the syringe with air in it. So we felt the springiness of the air inside the syringe, which gives a hint about the distance between the particles of air. So in other words, air being a gas can be compressed because there are large spaces between the particles, so the particles can be made to come closer to each other. Take note with that, guys. Okay, so as we push the plunger of the syringe, so we felt the springiness of the air inside the syringe, which gives us the hint about the distance. Yes, the distance between the particles of the air. But however, we were not able to push the plunger of the syringe with water in it. So, by the time na nilagyan na natin ng water yung syringe, no, we cannot or we were not able to push the plunger of the syringe. So, why? We felt the resistance of the water to being compressed. So the plunger could not be pushed because water is not as compressible as air. So gets? So the particles of liquid water are closer to each other, and it is difficult to push them even closer to each other. Okay, so nakuha. Okay, very good. Next. What we did in this activity shows the particle models of an atom, or the particle models of the three states of matter. So from the idea that matter is made up of particles and the situations that you observed, we can draw, or you can draw, no, or your drawing show how you see matter beyond what you can observe with your unaided eye. And because of this, you were creating your own mental picture and constructing models, which are drawings or diagrams that are representation of what is happening at a level beyond what your eyes can see. And this is what a science educators call the sub-microscopic model of representing an idea or concept which you cannot observe with your senses or even aided by a simple microscope. So in our discussions, we may have also thought of ways to make our models more consistent with the evidence we observed. So guys, at this stage, it is possible that the mental models we have drawn do not perfectly match those that you see in the books. So keep in mind that the models are not like not like the pictures taken by a camera. So they are only representations of reality. So the particle model of matter shows that in gases, so as what you can see in your screen now, the particles move at random directions very quickly and travel in straight line path. So in the process, they collide with one another and with the wall. Okay. So for example, in the balloon, so the gas particles move at random directions very quickly, and it travels in straight line paths. So in the process, they collide with one another and with the wall of the balloon. So they change direction only when they rebound from the collisions. So the distance between particles is large compared to the size of the particles. Look at that, guys. So the distance between the particles is large compared to the size of the particles. So just like what we have said earlier, that we can partially push the plunger with the air inside it, because it gives us the hint that the gas has a large distance between each other. Okay, next is the attraction between the particles is negligible because of the large distance between them. This explains why a gas spreads, because its particles fill all the available space in the balloon. Gases take the shape of the balloon because the particles are able to move freely to all parts of the balloon. So they move freely because they are far apart and there is negligible attraction between them. Okay, so this model also explains the compressibility of gases. The distances between particles are large, and so there is room for the particle to move closer to each other. And in liquids, okay, try to take a look. In liquids, the particles are closer to one another, so touching one another as they move. Since the particles are closer to one another, the attraction between particles is stronger than those in gases. Okay, the particles move and change positions, but not freely as those in a gas. Okay, as you observed in our activity, liquids can flow out of a container or a glass and can be poured into another while maintaining their volume. This happens because there are attractions among the particles of liquid which hold them together although not in fixed positions. These attractions also make it possible for liquids to have a definite volume. Take note, liquids have a definite volume. So this is one major difference between liquid and gases. So gases don't have a definite volume, while the liquids have a definite volume, and this is the one major difference between liquid and gases. The particles are attracted to one another more strongly than the particles of gases are. Okay, so when we pour the water and the styroballs in separate containers, we observe that a liquid such as water, it flows and it spreads out and take the shape of the container, right? And if you looked closely, as you pour the styroballs, the little pieces of solid styroballs maintain their shape even as the entire sample may take the shape of the container. So, meaning to say, solids have definite shapes and volume because the particles are packed closely together in fixed positions. They vibrate a little, but in these fixed positions, the particles cannot move around. So the particles of solids are held together by strong forces. One common characteristic of both solids and liquids is that the particles are in contact with their neighbors, that is, with other particles. So thus they are incompressible. So if you are going to try to take a look in our activity, as we push the plunger of the syringe with water, we cannot push it because there is water in it. Uh, and this is the reason why, because liquid is incompressible, and this commonality between solids and liquids distinguishes them from gases. So try to take note, gases is compressible while the solids and the liquids are incompressible because of the distances of their particles. Okay, gets? Yes, there are other properties that you will learn in grades 9 to 12 that will be useful for distinguishing among the states of matter. So, in general, the three states of matter differ because of the arrangement and motion of the particles in each state. Take note with that, guys, ha. In general, the three states of matter differ because of the arrangement and motion of the particles in each state. So far, based on our activities earlier, you learned that matter is anything that has mass and volume. So, and you now have a better picture or view of how the particles are arranged in three states of matter. We have solid, liquid, and gas. So, matter is made up of tiny particles, and particles of matter are moving all the time, and these particles have spaces between them, and the particles of matter attract each other. So these ideas are some of the features of what scientists call the particle model of matter. So in the next activity, guys, you will explain the changes that the changes taking place when liquid water is left in an open and enclosed container using the particle model of matter. You can watch in our next video the continuation of this discussion. So what changes takes place when water is left in an open container and in a closed container. So see you in the next video, guys. Thank you.